This image contains the entire B-movie script, and this picture of the Mona Lisa is worth exactly 1,401 words. But to understand how we got here, we're gonna need to go back a couple weeks. Guys, everyone keeps telling me that a picture is worth 1,000 words. Every day, everywhere I go, they say, hey Will, did you hear the news? A picture's worth 1,000 words. I don't believe it, okay? I don't believe it. I feel like you could put way more than 1,000 words in one picture. If you like use a program to put words in a picture and then use another program to take the words out of that picture, just using like the pixel data. You know what I mean? I know what I mean, so I'm gonna do it. Do you wanna figure it out with me? Excellent. Okay, so step number one is to create a program that can turn words into a picture. And we're gonna start out with just a binary, like black and white picture. I have some text that says hello there. So if I run this function, it gives me back a binary representation of the words hello there. But how does that actually work? Alright guys, buckle up, because it's time to learn. Shut up! Okay, so a computer uses bits to represent everything, including characters. No, not that kind of character. So each character is made up of 8 bits, which is also known as a byte. And this is stored in what's called ASCII format. So in ASCII, every character can be represented by a unique string of 8 bits. So like this is space, this is A, this is B, and so on. So my program takes the inputted text, turns it into a long string of binary numbers, and then plots that binary on an image going from left to right down the rows, where a white square is a 1 and a black square is 0. And that's how we got the picture that you saw in the previous clip. Now you should remember this because it might help you win a prize later. So obviously this is like super cool, and you can put any text into this thing. Like here's the Wikipedia page for grass, and here's the script for this YouTube video, but please don't read ahead. The problem is that we're not really storing our text very efficiently right now, because most pictures aren't just black and white. There's a lot of gray, and sometimes even color. So how can we use that to our advantage to put more words into the same picture, or to put less picture into the same words? Well, first let's talk about binary again. So I told you that 8 bits, 1 byte, can represent any character, but it can also represent any number between 0 and 255. If you want to learn more about that, click here to see my relay calculator video. I should clarify here that every character in ASCII is also a number, because its binary equivalent also transfers to its number equivalent. Okay, that's all. In a grayscale image, typically every pixel is represented from 0 to 255, depending on how white it is. So each pixel is given 1 byte, and each character is given 1 byte. So let's just match the pixel to the character. So I made a program that does the same thing as before, but instead of giving each pixel a bit, it gives each pixel a byte, according to the characters in the text input, and it fills them out in the same way. So here's that same grass Wikipedia page, but in a grayscale image. You can see it's smaller than the binary equivalent. And now we can take this a step further by putting in color. Okay, so a color image is basically 3 grayscale channels, one for red, green, and blue, all smushed together. And in a typical RGB format, each pixel holds 3 bytes. So I made a program that takes the first 3 characters in our text, assigns them red, green, and blue, and then pops them in a pixel. And then does that for the next 3 characters and the 3 characters after that. And now I have a program that can take whatever words I give it and turn it into a color picture, effectively holding 24 times the data in each pixel than with the binary program. And this can hold the same data in a way smaller image. For instance, here's the B-movie as a binary image, and then here's the B-movie as a color image. And it's kind of crazy to think that this thing can hold the entire script of the B-movie, but the math checks out. Here it is. Boom, top 10,000 most common English words. Boom, Constitution of Djibouti. Boom, my home address. But it's time to answer the question, how many words is a picture mathematically worth? Before we get to that, do you remember that prize I mentioned earlier? Well, the first viewer to decode this message will get a free ticket to OpenSauce, which is like this huge maker convention run by William Osmond. They've got like a bunch of content creators and keynote speakers. It's super cool. Now, this ticket is being given out courtesy of Hack Club, which is a non-profit charity organization that gives engineering resources to kids that want to make stuff. And they've sponsored this video. I'm here at their Vermont headquarters, where there's a bunch of teenagers just building resources for other teenagers to use. It's really cool. Right now, they're partnered with NASA to give you prizes like laptops, 3D printers, or even lunch with an astronaut just for building open source projects. And in their current program called Stardance, you can submit your project design and they will give you the money to make the project. And this is for beginners or advanced makers. Sign up right here and get money for your project, prizes for building projects, and a huge community of other kids that like to make stuff. Okay, it's time for the moment you've all been waiting for. How many words is a picture actually worth? There's multiple ways to approach it, so let's start here. What is the most words you can put in a picture? Now, I could do 4K, but I want to show this in a YouTube video, and a lot of people have screens that aren't 4K, so we're gonna do 1080p. So I counted, and 1080p is 1920 pixels wide and 1080 pixels tall. You multiply those together, you get in total 2,073,600 pixels. Now remember, each pixel contains 3 characters, so we'll multiply that by 3. 6,220,800 characters in total in our picture, and divide it by 4.79, which is the average number of characters per word according to this person on Reddit, and you get a grand total of 1,298,705 words in a picture. That is huge. Of course, I made a program that can do it, so let's do it. I need you guys to physically prepare yourselves for what's about to happen. This picture contains the Bible, the entire Bible, the Old and New Testament, Constitution of Djibouti, the Quran, the B-movie script, the Comcast terms of service, the speech they do at like the Disneyland rope drop. That's not very long, I just wanted to include the 29th President Warren G. Harding's inaugural address, and almost all of the Iliad. In this picture. That's crazy. It's hard to wrap my head around just how much data that is. This isn't even a 4K picture. We could put 4 times this stuff in a 4K picture. I'm gonna make the argument right now that this is the most important picture you're ever going to see. Okay, so here's the deal. In making these programs that make the images, I also made programs that turn images back into words because I wanted to make sure I was doing everything right. And something really interesting happens when you turn a regular picture into words. Not one of these static images that are made to be words, just a regular image. It's decoded in the same way, but instead of being readable words, you end up just with a ton of gibberish. Have you ever heard of that monkey typewriter thing, where if you have a bunch of monkeys typing on a bunch of typewriters for an infinite amount of time, you eventually end up with the complete works of Shakespeare? We kind of have something similar happening here, where because there's so much gibberish, you're gonna have some English words in pretty much every picture. I made another program that takes the top 10,000 most common English words and compares it to the decoded string from any regular image. And that way I can see how many words a regular image is actually worth. For starters, I put the Mona Lisa into this image decoder. And the Mona Lisa actually contains 1,401 English words. A couple of them being art and kind, which is sort of fitting, but also it's random, so you end up with other words like biz, CPU, and hot. Well, the last one applies, but you get it. I want you to think about this. The image I made, the image I cultivated, contains over 1 million words. And this picture of the Mona Lisa only contains about 1,400. And I'm not saying that my picture is more important than the Mona Lisa, even though it is. What I'm saying is one of these pictures is a culmination of human ingenuity and human culture over thousands of years, and the other one's kind of just a lady. And feel free to disagree in the comments below. There's this really cool image of the moon from the recent Artemis mission, which is great. 785 words, though. One of them is dust, so that's neat, but still, I don't know. And then there's this picture of George Washington on that boat. I don't know where he's going. Probably going to do something ethical. This contains 947 words. Way to go, Washington. Another fun fact, this picture of Tom actually contains Tom. So I guess the question maybe isn't how many words is a picture worth, but which picture is worth the most words? It's mine. Mine is. I want to talk about some technical details. The first thing that a few people might comment about is the fact that I'm using extended ASCII. My way of putting words into an image really isn't that efficient. Not only am I not using any compression algorithms, but I'm also using the entire space of 8 bits, 255 possible characters, when you could probably do the same thing with like 64, maybe 32 if you really just cut down to like lowercase letters and some punctuation. The reason that I did 8 bits is because it's very convenient to be able to put a character into a pixel, or 3 characters into a pixel with the color. The extended ASCII format is not a very compact choice for this, you know. Another thing I want to talk about is like some of the formations, if that makes sense, in this picture. You see a dark stripe in this image. What you're seeing is a bunch of capitalized letters. The capital letters in ASCII actually come before the lowercase letters, so they're lower down in those grayscale values. That's just the table of contents for the Quran. And then you might also see a bunch of bright spots at the bottom, and that's because in the Iliad, there's some spots with like apostrophes or weird punctuation, and a lot of that stuff comes at the end of ASCII, so you end up with brighter characters. So yeah, I just thought that stuff was interesting. Thanks so much for watching. This was kind of a different type of video than I've made before. Usually I do like hardware projects, but this this was just software. So let me know if you hated it. So let me know if you hate it and I should never do anything like it ever again. Remember to check out Hack Club if you're a teenager who wants free engineering supplies. And thanks so much to my patrons for helping me buy things that cost money. Check out these videos if you want, and remember to hype the video, even though I have no clue what that does and no one ever talks about it. All right, bye. Oh, no, that's fine. You can go back to doing whatever you're doing then. Sorry.